Assalamualaikum. I hope you are having a wonderful day. In this video, I would like to share about my research entitled The Performance of Taguchi's T method with Binary Bell Algorithm based on Great Value Priority Discretization for Prediction. The main idea is to integrate a swarm-based meta-heuristic algorithm known as the Binary Bell Algorithm with the Taguchi's T method prediction technique based on the Great Value Priority Discretization approach as the variable selection optimization for optimal prediction accuracy. So for starters, what is Taguchi's T method? Taguchi's T method is a multivariate prediction method introduced by Dr. Genichi Taguchi and the marlah-based technology system to forecast and predict future state or unknown output based on available or historical information. Fundamentally, the T method is developed based on the combination of regression principles and Taguchi robust quality engineering elements in formulating a predictive model such as simple linear regression, inverse regression, Taguchi's orthogonal array, and Taguchi's signal-to-noise ratio. In the conventional Taguchi's T methods, Taguchi's orthogonal array is employed as variable selection approach. It involves selection of suitable orthogonal array design based on the maximum number of independent variables, estimation of response or objective functions, computation of the average of variables levels, and determine the significant variable with assistance of factorial effect charts. However, there are concerns highlighted by past researchers where the orthogonal array offers a fixed and limited set of fractional factorial combinations to be accessed, and orthogonal array is lacking of exploiting the higher order interactions between variables to offer more combinations, thus resulted in suboptimality of T method prediction accuracy. Therefore, this research aims to find a better variable selection approach that will further enhance the prediction accuracy. The objective of this research is to integrate great value priority-based binary bell algorithm with T method as variable selection optimization approach and evaluates the effect towards the T method prediction accuracy. Briefly on T method methodology, this is the flowchart informating the T method prediction model involving several steps, namely data collection, unit space selection, signal data selection, normalization of signal data, computation of proportional coefficient and signal-to-noise ratio, computation of integrated estimate output value, and computation of integrated estimate signal-to-noise ratio as the quality index that quantify the model performance. Conventionally, the procedure of variable selection with Taguchi's orthogonal array approach consists of 4 steps. The first step is to select suitable orthogonal array design based on the number of independent variables. The second step is to compute the response of each combination in the selected design. Step 3 is to compute the average value of each levels for each respective variables. And the fourth step is to determine the significant variables. The relative importance of variable is evaluated in terms of the extent to which the integrated estimate signal-to-noise ratio deteriorates when the feature is not used. Briefly on the Bell algorithm, it was developed based on the natural echolocation's ability of microbats to identify prey, discriminate different types of targets, and avoid obstacles. Bats move in search space exploring for solutions by arranging frequency, velocity, and position using respective formula. Artificial bats conduct local search to further exploit the best solution in search for better solutions. The balance between exploration and exploitation achieved by updating loudness and pulse rate as search iteration grows. Binary Bell algorithm is a variant of Bell algorithm introduced to solve discrete optimization problems such as variable selection process. As for this research, a great value priority-based discretization approach to map continuous value to binary valued solution is employed during initialization of solutions and obtain new solution. Using this approach, the continuous bed position is converted to binary position involving 5 simple steps. The first step is to determine the continuous value of bed position vectors. In step 2, vector P is created by assigning the index position of the largest element in original vector X as the first element in vector P. In step 3, the index position of the second largest element in vector X becomes the second element in vector P. In step 4, step 3 is repeated until all positions of the element in vector X are filled in a vector P. The last step transforms vector P to binary value solution using binary operator. To evaluate the performance of proposed integration of great value probability-based binary band algorithm with T method, experimental study conducted using two benchmark datasets, namely heating load and abalone datasets, obtained from UCI machine learning repository. A 70-30 whole-out cross-validation applied to the datasets for training and validation purposes. In this study, unit space data consists of 5 unit data and excluded from signal data. Table 4 shows the average of unit space data. Prior to variable selection executions, the base T method predictions model was formulated. Therefore, the model parameter, proportional coefficients, and signal-to-noise ratio were computed. Table 5 and 6 shows the computed model parameters using trained dataset for heating load and aberrant dataset respectively. In this study, the parameter setting for great value probability-based binary band algorithm is determined through Taguchi's method approach. Involving several factors, 3 levels resulted to the selection of L27 orthogonal array. The selection of level value in table 7 is based on compilation of past research parameter setting used for the binary band algorithm. Optimal parameter setting for each dataset successfully obtained as shown in table 9. To determine significant variable using great value probability-based binary band algorithm, the algorithm is executed 20 independent runs with 500 iterations each. The objective function is to maximize the integrated estimate signal-to-noise ratio, and the selection criteria is based on 50% and more appearance as significant variable over the 20 runs. As for the experimental result, table 10 shows number of variables, optimum combinations, and the reduction rate for both datasets based on T method without feature selection, T method with orthogonal array, and T method with great value probability-based binary band algorithm. In general, through variable selection process, a better subset of significant variable was found, resulting to reductions of number of independent variables. Heating load dataset recorded 62.5% reduction rate of number of variables from 8 to 3 variables for the T method with orthogonal array, and 50% reduction rate from 8 to 4 variables for T method with great value probability-based binary band algorithm. As for aberrant dataset, T method with orthogonal array recorded 57.1 reduction rate from 7 to 3 variables, while the T method with great value probability-based binary band algorithm recorded 71.4% reduction rate from 7 to 2 variables. Using this optimal subset of significant variables, the prediction accuracy using mean absolute error metric computed using validation dataset as shown in table 11. T method without variable selection recorded 8.06 and 3.65 MAE or mean absolute error for heating load and aberrant dataset respectively. The T method with orthogonal array recorded 29.7% and 10.1% improvement of MAE over T method without variable selection process for heating load and aberrant dataset respectively. The T method with great value priority-based binary band algorithm recorded the lowest MAE for both datasets at 5.23 or 35.1% improvement over T method without variable selection, and 3.23 MAE or 11.5% improvement over T method without variable selection for heating load and aberrant dataset respectively. Finally, table 12 shows the result for hypothesis testing analysis using paired t-test. The p-value for heating load dataset less than 0.05 significant level suggests that there is a statistically significant mean difference between the outcome obtained between the T method with great value probability-based binary band algorithm and T method with orthogonal array. As for aberrant dataset, the p-value failed to reject null hypothesis, thus suggests that there is no statistical significance of mean difference between the outcome of both methods. As for the conclusions, the integration of great value probability-based binary band algorithm for variable selection with T method resulted in Number 1, reduce number of independent variables. That leads to less complexity of t-method predictions model. Number 2, better subset of significant variable found. That enhance t-method prediction accuracy. Number 3, the recursive and adaptive feature of the binary bell algorithm ensure that a better variables combination is obtained in solution space. And number 4, great value parity discretization technique fuse well with the bell algorithm as the procedure is simple with low computational cost. Thank you.